Hi guys, welcome back. I hope you're doing well and that you're ready for a new episode. In this one, we will add collision detection to our player versus the level tiles. There will be another collision episode later for objects versus objects, such as the player attacking an enemy. But we need to start with adding collision checks with the level tiles. So let's begin with that. But as usual, a recap about the last episode. We managed to get our level to be displayed in the last episode. We started by adding a few int values that will help us keep the size of the game at a good ratio, and also make sure that in case we change the size of the game, we don't break the game and we don't have to change it in several places. We just have to change it in one place. We also added two classes, one for the level to hold all the data of that level, and one manager to manage all our levels. Right now there's just one level, but there will be more. We also looked at different types of level editing and selected the one that will fit us the best. Then adding some code to handle the level files, we ended up with the level from that. And that pretty much sums up the last episode. Now, let's begin with this one. How this collision will work won't require much in terms of explanation. We need to check so that the player will not overlap with the level tiles. First, we will just use the entire size of the image, 64 by 40. But that's not actually the size of the player, just the sprite image size. Once we got the sprite image able to detect and avoid overlapping the level tiles, we will make the hitbox for the player. And this hitbox will be the foundation for collision detection with the level, but also later, for example, projectiles, if we add that. We will achieve this by checking the four corners of the player, the top left, the top right, bottom left, and also bottom right. And if any of those points overlap a tile, then we cannot move there. But if there is no overlap, then we can move the player there. And of course, this check is going to be done before we move the player. So yeah, that's a quick explanation. Let's begin coding. And we're of course going to start with a hitbox for our player. And we're actually going to place that inside our entity, because our player will need a hitbox and also our enemies. So the entity will contain the hitbox. So we need a protected, and the hitbox is actually going to be a rectangle. And rectangle is just a very easy to use class that stores an XY width and height just like this. But we can also check for if a certain position is inside this rectangle or not without having to do a lot of the code for it. But we need a name for it, so we're gonna call it hitbox. And we need to import that class, import rectangle. And just to show what we have here with our hitbox, actually let's just keep it all lowercase. I think that's better. And with our hitbox we can, first of all we can get the values, X, Y, width and height, just like the ones we have here. But we can also check whether or not it contains a point, if it contains a rectangle, position, etc. So it's a lot of useful methods already inside the rectangle class, so we don't have to code it out. But we are going to create a method here that's going to initialize the hitbox. And we're gonna call it init hitbox. And this hitbox, as I mentioned in the description how we're gonna do this, first we're just gonna create the hitbox out of the entire sprite image. So that will just be the exact same values we have up here will be for the hitbox. But later on we will have a smaller hitbox. So we need to call hitbox equals new rectangle, and we're just gonna pass in X, Y, width and height. But this entity cannot take in floats, so we need to cast X and Y into integers. Like so. And now we have the hitbox. And there is a few methods that I already know from experience that we're going to need. We're going to need a public. I think we're going to have public. Yeah, let's keep it public for now. Easiest to use. And it's going to be a void update hitbox. And what this update hitbox is going to do is going to take the new X and Y and put it to our hitbox. So hitbox.x equals, and we need to cast it over to an int, and then hitbox.y equals hitbox like so. And now we updated the position. The width and height we don't need to worry about because they are always going to stay the same. So we don't need to worry about that. And we also need a getter, so public rectangle get hitbox. And we're going to return hitbox, like so. Actually, let's make our update hitbox a protected method. I only want whatever is extending entity to be able to update. So player will be able to update it, but if we try to go from our game, player.update doesn't exist. So yeah, it should be the player class or the enemy class that actually updates the hitbox. But yeah, now we have everything we need for our hitbox for the moment. But there is actually one thing I want to add in here. I think it's the best to actually add in here. Yeah, and it's going to be the one that draws our hitbox. And it's going to be a protected as well. Protected void draw hitbox. And it's going to take in the graphics. Oops. Graphics G. And we also need to import it. And we can actually add a comment here for debugging the hitbox, just so we know why we have it. And we want to set g.set color. And we want something that's very easy to spot, so maybe red color or actually color dot, I think we have pink. Yeah, let's go with pink. It's a good color when you use it. If it's too bright, we change it, but that we will see later. And then we want to draw a rectangle. So g.draw rectangle, and we're going to go hitbox.x, hitbox.y, width and height, but we're going to use hitbox.width, and of course hitbox.height, like so. And that's good for now. So inside our player class, update position, animation tick, set animation. After update position, we say update hitbox. And that's good. Now we have the drawing, and I think we're gonna have the hitbox drawn on top of the player. So we just call draw hitbox, like so. And if it's working now, we should have a hitbox when we start the game. And we do. We have a hitbox. And it's following the player perfectly, like we want. If the player moves, the hitbox moves. And what we need to do now is to make sure that our collision works. We have no way of detecting if we are inside a tile or not. And we should also not allow the player to go inside the tiles. So that's what we're gonna do next. So let's get that going. And there's many ways we can check the level data with the player position in order to check if there's a tile there. But I think the easiest way to do this is to store the current level data in the player class itself. So inside our player, we add a private integer to the array LevelData. And we're gonna add a method right underneath our load animation. We create a method called public void load LevelData. And it's going to do exactly that. So integer to the array LevelData, this dot data equals LevelData. And let's go to our game right away. And where we initialize the classes, there's the player, then we have the level manager. Let's actually move level manager above the player. After we initialize the player, we say player.load LevelData. And inside our level manager, we're gonna get the current level, but we don't have that. So we go in here, in our public, underneath our public, we add a public level, get current level, return level 1. As we only have one level, we're going to return this one, but later on we will have an array of levels, and then we're just going to use a index pointer and get the current level. But I think that's good. And inside our level, just a quick check. we have no way of returning the level data. So let's add a method for that. So public integer to the array get level data, then return level. So in our game class now, level manager dot get current level, then get level data, and now our player have the level data stored. It's not the best way of doing this, but for now, instead of adding a lot of other stuff, let's just keep it in the player class, and then later we might move it into some other class and then just use that one for all our enemies and also the player. But for now, let's keep it in here. So before we actually move the player, we want to check whether or not we can move the player. So we're going to need a method that checks the current position plus the speed or minus the speed, depending on what direction. Can we move there? Then we move there. And the best way to do it would be to add another class inside our utils package. And this class we're going to call help methods. And this class will have a few static methods that takes in some data and then returns some value. But these methods can be used for more than just the player, and that's why we're going to add it here. And the first method will be the public static boolean CanMoveHere, and it's going to check for the position and if that position overlaps any type of tiles. So we're going to need a float x, float y. We will also need the int width of the object or player, then int height, and also the level data. And now we're going to check all four corners of this temporary rectangle, if you will. And we're actually going to test the top left and then the bottom right. Because sometimes we will go diagonal, and if we're going diagonal, it's always going to be one of those two that will be inside a tile, if there is a tile. And we don't know if you're going left here or if you're going right here. So that's why we're checking top left and bottom right first. And then if those two are false, then we can check bottom left and top right as well to check if those are. If all of those are false, meaning that there is no tile on any of those 4 points of this rectangle, then we return true. However, if any of those points return true, then we return false. So yeah, let's get started. But we do need another method in here, and it will be a private static boolean as well. And we're gonna call it isSolid. So it's going to check whether or not it is a tile, but also checking so that the position is inside the game window, like so. So first we're going to need the position, which is a float as well, and float y. And we also need the level data, like so. First, we're going to check if x is less than 0, or x is more than game.gameWidth. And if that's the case, we return true, meaning it's solid, so don't go here. And we're also checking for y direction. Y is less than 0, or y is more than game height. Return true as well. If none of those fails, meaning we are inside the game window, then we're going to figure out where in the array we are, where in this level data we are. So we need a float actually, x index is equal to x divided by game.tile size. And also float y index is equal to y divided by game.tile size. And with these two float indexes, we get a value from our level data, but we can't pass in two float values, so we're just going to cast them over to integers in there, and we keep them as float values for as long as possible, but when we're passing them in here, we're changing them to a integer, so x index, and then int for y index. And that will return a value. And we're going to check if this value is a tile. So first we're going to check if value is more or equal to 48. We only had 48 sprites, so 48 and up will be no tiles at all. But we also need to check if value is less than 0. For some reason, maybe we get below 0. That's also not a tile. And the last one is if value is equal to 11, I think. I think that was the one that was transparent. Let's take a look. The 12th sprite is a transparent sprite. So that one we should also be allowed to pass through. And if any of these are true, then return true. Else return false. All we have to do now inside our CanMoveHere is to start by adding those points into this isSolid method. So the first point we're going to check is the top left, so it's going to be if isSolid and x and y and also LevelData. And we're not going to check if it is solid. We actually want it to be continuing as long as it is false. Meaning we have not found a solid one yet, so let's go down to the next one. If that one is not solid, then we check if not is solid. And we just check the top left, so we want to check the bottom right. So that is x plus width and y plus height. And then of course LevelData. And if that one is also not solid, then we can check top right. So if not is solid, it's x plus width and y and LevelData. And the last one is going to be if not is solid, then x and y plus height. And if all of those, also LevelData, my bad, LevelData. And if all of those checks are false, that means that we can move there, so we return true. But if any of those fail, we return false. Before we continue, there's a few things we need to fix. And I took a look at the code a few days later. Well, it's a few days later for me, it's instant for you. And the first problem is right here. It shouldn't be more than just game width. It should be more or equal than game width and of course height. We might actually be at the very edge of the game screen when we're testing, so that would result in a index out of bounds error. And the second one is, well, right here. It's not xy, it's yx. That's something that I missed, and we're not checking if value is equal to 11. We're checking if value is not equal to 11. Because if it's equal to 11, we should not return true, because that's a transparent tile and it's not solid, so we should return false. So, I think that is all of the fixes we need to do in here. Now we can actually go to the player class. And we're going to start inside our UpdatePos method. And the first we're going to do is to check whether or not we're clicking any button. So if you're not holding down anything, then we shouldn't be in this method at all. So first, if not left, and if not right, and if not up, and if not down, then we just return. There's no point in being here. And we can actually, right underneath here, add two floats, float x speed and y speed. And these two variables is going to be initialized here, just like so. And they're going to be a temporary storage of the speed in x or y. And then we can pass that into our CanMoveHere method. And if it returns true, then we apply it to the actual position of the player. So instead of x minus equal player speed, we say x speed is equal to negative player speed. And we're going to remove the moving. We're only going to say moving is true if we can move somewhere. If it can't move anywhere, then we're not going to have the moving animation. So we might just remove them all at the same time. Then it's x speed is equal to player speed. Y speed is equal to negative player speed. I think minus equal player speed will work too because we initialized it, but this looks more correct in my opinion. Then speed is equal to player speed, like so. And then we can remove all these brackets because it's only one line of code. Format it a little bit and looks better. All right. Now we can actually start the testing. So first we need to import the method that we created in our help methods. So right underneath here, import static utils.help methods, CanMoveHere, and we're gonna import that class. And then back down into our update position, we call if CanMoveHere, and we're going to apply the current speed plus x speed, and then y plus y speed. Then we need the width, the height, and the level data is already there. And if this is true, then we say this.x plus equals x speed, this.y plus equals y speed. Should be nothing like that, like so, and moving is equal to true. So I think that is all we need for now. So the next x position, the next y position, width, height, and level data. So let's give this a try. All right, we can move the player. Let's see if we hit the wall. And we did. But one problem we're gonna realize is that we can move through these single tiles if we never hit any of our corners inside them, which is something that's gonna disappear when we shrink our hitbox. And just to check so we get no error, nope, I can try to go outside, but it's blocking there as well. Perfect. Let's work on making our hitbox smaller. To change the size of our hitbox, we need to take a look at our sprites. Our player is about 20 pixels in width and 28 pixels in height. Here we can set the size to something that we feel will be the size of the hitbox. We care more about the body, head, and the legs of the player. Arms is not that important. We don't need to be 100% accurate here. The body will be what is colliding with the level, not the arms. Now with the selected size, we can then calculate a few values. The distance from 0, 0 to the start of the hitbox. The hitbox starts at 21x and 4y. This will be by how much the offset will be when we render the player sprites in the game. And we will begin inside our entity class with this. And the first thing we're gonna do is to change rectangle into a 2D.float. We're actually going to need to use float values inside our hitbox. And since we're using floats, we need to recast these all into integers for drawing the rectangle. And the last one. All right. And when we are initializing it, we can remove these ints and also call it 2D.float. And that should do it, I think. Yeah. And when we update the hitbox, we're actually going to remove this method. We can actually comment it out for now. We're not going to use it. And when we're returning the rectangle, we're going to return a 2D.float, of course, because that's what it is. And we need to change how we initialize the hitbox, because now they won't be the same as the starting position of the enemy and the size of the sprite image. So we will manually call the init hitbox from our player class. So we will pass in a float x, float y, float width, and float height. Just like before, but now we get to set the values inside here, and it should not be a private, it should be a protected, like so, and then we can remove init hitbox from our entity constructor. So I think that's all we need to do here. And then inside our help methods, we're actually going to change the parameters for this method, which will be a float width and float height instead of ints. Because we're going to pass in the width and height from the hitbox, not the sprite image. And the hitbox is in float values. So that's why we need to change that. And I think we can close that method. And now we get to work inside our player class. And first we're going to create two variables, private float x draw offset. will be equal to, and it will be 21, which was the offset that we calculated to where the new hitbox should start versus where it usually starts, from 00 to 21x and 4y. And then of course we need to use game.scale. In case we scale the game up, we need to also follow along with that. And we also need one for y, so float y draw offset is equal to 4 times game.scale. And inside our constructor, we're going to call init hitbox. And we can pass in these x and y, but we're actually going to base our position not with these, but with the hitbox x and y. So we can pass in these, it doesn't really matter too much. And the width was, what was it, 20 times game.scale is also important. And the height was 28 times game.scale. So far so good. Our update hitbox, we can remove that. And when we draw the player, we're not going to use these. We're going to use hitbox box.x minus x draw offset. But this is a float and that's a float too, so we need to just cast them over to integers. And the same for this one. So int and hitbox.y minus y draw offset, like so. The width and height will be the one we're passing in, which is the size of the sprite image. So these two we will not change, so they can remain integers. Then we draw the hitbox and everything there is alright. But down here in our update position, we need to change this method just a little bit. So we can actually just copy that and comment that out so we can see how it looked to how it will look. So instead of x plus x speed, it's actually going to be hitbox dot x plus x speed. And that's why we changed this method, because I knew that was gonna happen, so we had to change it. And then of course hitbox.y plus y speed, and the width and height is wrong. It should be the hitbox.width and hitbox.height. And the level data should be the same, and that looks alright. But we're not going to increase x and y. We are going to increase hitbox.x and hitbox.y. And then of course moving equals true. And I think everything else should be fine. Yeah, let's give this a try. And yeah, that looks pretty good right now. And just to test if it's going to work at a smaller scale, because right now we have 2, I think. Yeah, 2 in scale. Let's just go with 1 in scale and see if that works too. Yeah, that works too. Beautiful. So we got the hitbox working at a smaller scale, and the player is drawn in the center of it. Wonderful. Alright, my friends. The episode have come to an end. We finally got some hitboxes working, and granted, there's more ways to implement collision detection into a game. This is just one of them. I hope that you have learned something useful today, and if you have, why not smash that like button and also subscribe. It would help this channel out. I also want to take a moment to thank you all for the 900 subscriber milestone. That's really cool. We are soon at the 1000 mark. Until the next episode, take care now and have a wonderful day. Bye.